Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. Let's see this problem. We are given a binary array and we have to find count of maximum consecutives 1 present in this array. Here we have to understand two things first. First, this is a binary array and binary means 2. It means there are two possible elements present in this array. Either it is 1 or 0. Second thing we have to notice here that we have to find consecutive ones. Consecutive basically means we have to find count of total number of ones appear continuously. Okay, so let's understand this problem with some examples. In first example, we are given an array like this 0 0 1 1 0 1 and the output of this input is 2. The reason is simple. Here you can see there are two ones and here is only one 1. So the maximum of 2 is 2. Okay, that is why the output of this input is 2. In next example, we have three elements 0 0 0. In this array we do not have any 1. That is why the output of this input is 0. So what we have to find basically in this problem, we have to find count of maximum consecutive ones present in the array. Okay, I hope now you understand this problem really well. So let's pause the video and think about an algorithm to solve this problem. Alright, I hope by now you would have written at least basic program to solve this problem. Okay, so now let's look at the brute force approach to solve this problem. We are given an array and it is a binary array with elements 0 0 1 1 0 1. Okay, so the idea for brute force approach is pretty simple. First, we are going to initialize a variable max equal to 0 and this variable is going to help us in tracking how many consecutive ones we have seen so far. Okay, and then we are going to run a loop from 0 to n-1 to pick one item or one element at a time. Okay, then inside of this loop we are going to run one loop again, but before this loop we are going to initialize one variable count, and this variable help us in keeping track of number of elements. So what we have to do basically, we pick one element at a time. So let's say we pick 0 and then we are going to count number of consecutive 0 appear in this array. Okay, then we move to next element and this element is also 0. So we are again going to count maximum consecutive 0 appears in this array. Okay, and then we move to 1 and again we are going to count maximum number of consecutive ones present in this array. So when we are at this position, we get 2 as the maximum consecutive ones. Then we move to 0, we get count as 0. Then we move to 1 and we get count as 1. Okay, but here we can do some optimization, as we know that we do not have to count the number of consecutive zeros. So we can do one optimization here, that whenever we encounter 0, we just break the loop. So it means for this element the inner loop is not going to work. For this element also inner loop is not going to work. But whenever we see 1, the inner loop works now. And it's going to count all the numbers beginning with this number. And now this is going to count all the elements beginning with. So basically what we are doing here, we are running a loop from 0 to n to pick one number at a time. And then we are running a loop, inner loop, to find the consecutive elements beginning with this element. Okay. If we find 0, then we reset count to 0 and break the loop. And if we encounter 1, then we simply increment the count by 1 and we calculate the maximum between max and count. Okay, and let's say if we found that the count is greater than the maximum, then we set maximum to that count. So this is the simple idea to solve this problem. Now let's see the implementation of this basic approach. So here is the implementation of this basic approach. We have function. That function is taking array as input. Okay, in first statement we are taking length of, in first statement we are getting length of the array, and in second statement we are initializing max to 0, and this max is going to keep track of all the consecutive ones we have seen so far. Okay, and then we are running a loop from 0 to less than n, and inside of this loop we are initializing count variable to count number of consecutive ones. Okay, and inner loop is running from I to less than n. Okay, because if we are at this position, then again we have to count all the consecutive element beginning with this element, right? If we are here, then we are going to count all the consecutive elements begin with this element. That is why we are running loop from I to less than n. And inside this loop, if we found that the current element is 1, then we are simply incrementing count by 1. And if we found that this element is 0, then we simply break this loop, because we do not want to count of consecutive zeros at all. Okay, and after running this loop, we are going to calculate maximum between max and count. If we found that the count variable is larger than maximum, then this math function is simply return the maximum value, and it's going to set in the maximum variable. Now let's dive into this function and see how it works. Okay, so we have array 0 0 1 1 0 1 and we initialize max to 0. Our loop begins and the value of I is 0. The element present at 0 index is 0, so we simply break the loop. In next iteration, our I becomes 1. Again, element present at index 1 is 0, so we break this loop. In next iteration, I becomes 2. Element present at index 2 is 1. Okay, so we initialize count to 0, and then we run a loop from second index till fourth index. Okay, because at fourth index we are going to break this loop. So we get the count. As 2, and we compare this count with max variable. We found that 2 is greater, so we set our maximum to 2. It means there are 2 consecutive ones we have seen so far, and it is the maximum. In next iteration, our I becomes 3. The element present at index 3 is 1. Again, we are going to run inner loop to calculate or to find the maximum consecutive ones beginning with this index, and after one iteration we get the 0, so we break the loop. So this time the count variable becomes 1, and again we going to compare this C with maximum. We get maximum as 2 only. Maximum of 2 and 1 is 2, so we keep the maximum as 2 only. In next iteration, our I becomes 4. The element present at index 4 is 0, so we simply break the loop. In next iteration, our I becomes 5, so the element present at index 5 is 1. Again we initialize C equal to 0, count is 0, and run a loop to count number of consecutive ones. This time we get C as 1 because this is only one element, because there is only one element present here. We again going to compare this C with the max, and we get 2 as maximum. For this input, the maximum consecutive ones is going to be 2, and you can see here that there are 2 ones appear here, and all other are 0, and here we have only single one. So this is how this is going to work. Now talking about the time and the space complexity of this function. What happens? Our outer loop is going to run n times, and in worst case, if we get array like this 1 1 1 1 1 1, our inner loop is going to run n times. So we can say that the time complexity of this function is going to be big of n square. N into n is equal to n square. And as we are not using any extra space other than few variables and the input array, that is why the space complexity of this function comes out to be theta of 1. So this approach took big of n square and theta of 1 constant space to solve this problem. So this is the brute force approach. But we always ask one question to ourselves, that can we do it better? As you can see that this is the quadratic order of growth. But can we do it better? Can we reduce the time complexity to big of n? Do we have any other approach to solve this problem in big of n time? So do one thing. Observe the input array once again and think about a solution that can solve this problem in big of n time. I hope when you observe the input array, you are definitely going to get some ideas that will help you in solving this problem in big of n time. Alright, now let's talk about the efficient approach to solve this problem. So here is our array. This array is binary array, and there are 0 0 1 1 0 0 1 elements present in this array. So the idea of efficient approach is, first we are going to initialize two variables max and count to 0. The max variable keep track of maximum consecutive ones we have seen so far, and this variable is simply going to count number of ones. Okay, and then we are going to traverse an array from 0 to n minus 1, and in each iteration we check if the current element is 0 or not. If current element is 0, then we simply reset the count to 0. And if the current element is 1, then what we are going to do? We are going to increment count by 1. This way we keep track of number of consecutive ones. And in each iteration after incrementing count, we compare this value of C with maximum. Okay, and after comparing, we found the maximum of both the numbers and set it again to the maximum variable. So let's say we are here at 1, so we increment the count by 1, so our C is going to be 1, so our C becomes 1. Then we go to next element, we again see 1, so we increment the count by 1, now our C becomes 2. In next iteration we see the 0, so what we have to do, we simply reset C to 0 because now we encounter 0. But while traversing 1 and 1, in each iteration we compare the value of max and C. So at this point our value of C is 2, so we compare max with C, max is 0 and C is 2, so it means 2 is greater, so we set maximum to 2. So this is the simple idea to solve this problem efficiently. Now let's see the implementation of this efficient approach. So here we have a function find consecutive ones. This function is taking array as input. In first statement we are getting length of array. In next statement we are initializing max and count to 0, and then we are running a loop from 0 to less than n. In this loop, using if statement, we are checking if the current element is 0 or not. If current element is 0, we simply reset the value of count to 0. If it is not 0, then we are going to increment count variable by 1. And after incrementing count variable, we compare the count with the max, and after comparing we get the max and we store that value in the maximum variable. Okay, and after loop gets completed, we return the value of maximum variable, and that is going to be the maximum consecutive ones present in the array. Now let's dive into this code and see how it works. Here we have array 0 0 1 1 0 0. These are the indexes of this array. We initialize to variable max and count with 0, and our loop begins. Initially value of I is 0 and element present at index 0 is 0, so we simply reset the count as 0. Although it is already 0, but we are still resetting it to 0. In next iteration our I becomes 1, element present at index 1 is again 0, so we again reset count to 0. In next iteration the value of I becomes 2, element present at index 2 is 1, so we increment count by 1. It means we have seen 1 1, right, 1 1. And then we compare this C with the maximum. So maximum is 0 and C is 1, and which is the greater number? 1 is the greater number, so we set our maximum to 1. It means so far we have seen 1 1, first one. Okay, in next iteration our I becomes 1, in next iteration our I becomes 3, and element present at index 3 is 1, so we increment the count by 1, it becomes 2. Now we again compare 2 with 1. Okay, and the maximum of 2 and 1 is 2, so we update our max to 2. So far we have seen 2 consecutive ones. Okay, in next iteration our I becomes 4, element present at index 4 is 0, so we simply reset the count to 0. In next iteration our I becomes 5, element present at index 5 is 1. Okay, so we increment count by 1 and we compare this 1 with max, and the maximum of both the numbers is 2, so we keep our maximum as 2. So by the end the output of this input is going to be 2. Okay, so in this efficient approach, how many times we are running loop? It is clear that we are running loop n times, so the time complexity comes out to be theta n, because we are running loop exactly n times, and space complexity is going to be theta 1, because we are not using any extra space here to solve this problem. So this approach is taking theta n time and theta 1 constant space to solve this problem. Got it? Before we end this video, let's have a quick recap of what we have learned so far. So we are given an binary array, and our task is to find maximum consecutive ones present in this array. Okay, we saw the brute force approach first to solve this problem, and this approach took big O of n square time to solve this problem, and then we saw the efficient approach, and this efficient approach took theta of n time to solve this problem. So I hope now you have a good understanding of how to find maximum consecutive ones present in the binary array. So this is it for this video. Thanks for watching and see you in the next video.